Welcome to the Complete Python and PostgreSQL Course 2.0. My name is Salvatierra and I'll be your instructor in this course. I'm a software developer turned online teacher with over 120,000 students on Udemy. I'm also the founder of Teclado, where I help my students level up their coding. Today I'm here to help you learn, use and eventually master PostgreSQL and how to use it from your Python apps from scratch. You'll need no PostgreSQL or database experience at all. Some Python or programming experience will be helpful, but we've got it. PostgreSQL, also called just Postgres, is one of the top relational data in the world, used by giants such as Instagram, Skype, The Guardian, even. But also, after taking this on Postgres, you'll find it really easy to learn relational database systems such as MySQL. The concepts are really similar. Postgres is more advanced features, JSON and key value storage, and is free and open source with an excellent team of users. In each section, you'll learn how to extend Python projects to add more and more functions. You learn about the fundamentals of SQL, such as creating tables and retrieving data, relational data, and how to work with it using joins. We'll explore PsychoPG2 to interact with PostgreSQL EPUN, advanced querying, state queries, views, functions, and stored processes, how to work dates and times correctly so you don't run into some very common problems, how to plot graphs and charts with your data, and much, much more. So by the end of this course, not only will you know and understand everything you need to know about databases, you'll also have tons of experience using Postgres in your pipes. Whether you're a Python developer who wants to start harnessing the power of databases, or maybe a sysadmin or data analyst who wants to take the best of Postgres, this course is for you. So there you have it. If you want to learn more about databases and Postgres, join the course. I'll see you on the inside. Hi guys, and welcome to your first video in this Python refresher. Let's talk about variables. A variable in Python is a name for a value. You can think of them as similar to those in algebra, but there are slight minor differences that you'll understand as you program more in Python. Here's how we define a variable. You can define the variable name, for example, x, first. So here, okay, you're going to use the value 15, create that or store that somewhere, and then it's going to say, and what am I going to run that value as? X. The right side of this side, the left side happens later. As there are few values in Python, Python has already created them before you create these values when you use them, but if you have selected 100, I will do what I just said. We create this value and store it. Let's make a name for this value. As integer, here you can define variables such as 9.99. Here what I mean is a float or a value floating point. And then I've told Python to give that value the name of price. Let's say we've got a variable called discount and it equals 0.2. We can then say that the final result of this discount is applied would be the price multiplied by 1 minus the discount. And here's what happens when you execute this. Of course, following the rules of match and does first, since it's between brackets, 0.8, 1.02. Then you're going to multiply 999 by 0.8, and that value will be calculated and stored in Python's memory. Whatever that is, with them from here on. If you want to print the value, you can very easily do that with the print function. So here we will type print, and then inside bracket we will type result. The brackets here are not as they are up here. Here they were used for order of preference in mathematical applications to signal to the print function what we want to print. This is in Python. Whenever you see a name such as print, follow these brackets, what is a function. Anything performs an action, such as showing something to the user, or it calculates an output based on inputs. or it can do both. We're gonna look more at functions in a video, but this is how you'd show the user something in the console. So I'm gonna save this file, and you can see that the output is 7.992. So this output here is what's line 8, this print 8. Notice we've got a number of other variables up here, but we are not printing them out, so they will never be shown. As well as floats has a called string in mathematics or for calculating things, whereas strings are used to store a person's name, a person's date, so on. Even though some of them are numbers, they're not going to be used, so we can store them in a string instead. Let's say that we want the name to be stored. What we'll do is we will say name equal, and inside quotation marks we'll type off. What Python does is it creates this and then this name here for that string. Notice that you can reassign a name, so that we can do things like, and now name, instead of being a name for Rolf, will be a name for Bob. So it's created here, it's just name variable. You can of course print this out if you want, and I will save this file and run it, and you'll see down here that we get Rolf printed out because that is a string. Python uses the quotation marks to signal a string, but these quotation marks themselves are not part of the contents. They are just used as delimiters. Instead of double quotation marks if you like, and that is totally fine as long as you don't mix and them. Then that won't work and Python will complain. I recommend you always stick to one of, and I generally use double quotation marks. If we print the name multiplied by 2, which is how you would multiply any number. If you run this, you'll see that the output is now Rolf, because that's line 3, and then you get Rolf for line 4. What's happened here is this has essentially done name plus name. They two names together. That's the same meaning as the multiplication. And the string is join them, and it will add one after another, so you can end up with a longer string. It can be very useful at times, but normally is not what you want when you multiply a string by a number. Let's say you have 2 equals 25 equals a. I mentioned earlier that 25 is a value is under 255. So Python creates as it was a larger value created. So we get the chart. We say that a is a name for that. Here on we refer to a, and really we'll be referring to the value equals a. Well, Python is going to use a, and it's going to say, okay, a5, so we're going to use 25 here instead. So this means the same thing as this. And is now a name for a. Really means that b is a name for 25. Now, both a and b are names number 25. So you can verify that that's correct by printing them both out. So I'm going to print a and b, so we 25 and then 25 is perfect. But what happens if we do b equal 17? Should a be 17 as well? That. And now down here, you get 25 and 25 for lines 4 and 5, and then you get 25 and 17 for lines 9. What we've done here in line 7, when we said b equals 17, is we've told Python to evaluate the value 17, and then make sure that b is a name for 17. Python completely got that b name for something else before, and it just says, okay, this b name for 7 a is completely unchanged. The assignment expression, when like this, doesn't change other variables. It just changes the variable that you refer to. There are ways for us to change a by using b, but not talking about this. We will talk about that later on in the videos when we learn about mutability in language. Alright, that's it for this Python refresher on variables. Do remember that this is not a Python introduction course, because we've talked about some quite advanced things here, but it's just to get you back up to speed with Python in case you have experience for or with other programming languages. Thank you for joining me in this video, and I'll see you in the next one. Hi guys and welcome back. In this video we're going to look at an overview of the project we're building in this first section. The project is a programming journal that uses SQLite as a database. In this journal we're going to be able to add new entries or view existing entries, keep track of our programming learning. When users first run our app, they're going to see a sheet like this one, a quick welcome at the top, and then the three options that they've got in the menu. 1 to add new entries, 2 to view entries, or 3 to exit, and finally they can enter their selection at the bottom. To add new entries, the user is first going to press 1 to enter that option in the menu, and then ask them for the date and contents of the entry. These are going to be two separate prompts, so the contents are going to go in one prompt, one input call, and the date is going to go in another prompt. Something like this. So the what have you learned today is a prompt. The user will type behind that and will tell us what they've learned today, and then we'll ask them for the date, and we're going to store both of those things in our database. If the user presses 2 in the menu instead of 1, then we're going to show them their entries, and for each entry we'll show the date and the content of the entry. Something like this. So here you can see that on the 1st of January, the user learned how to start coding with Python and SQL, and then on the 2nd of January, they worked with some more SQL, and so on. Of course, notice that the dates here could mean different things in the United Kingdom and the United States, for example, but we're not going to worry about dates, date formatting, and things like that in this application. We'll look at that later on when we learn more about working with dates in SQL. Finally, after the user makes a selection and we perform the appropriate action, be that to add an entry or to view the entries, they can choose another, and we will continually ask them to choose another option until they decide to exit the application by entering 3. So here's the complete flow of our application. Let's say that the user starts by adding a new entry. They enter 1 down there at the bottom. Then we ask them what they've learned today, and they enter the date. And then we ask them again to select another option, and this time they enter 2. We will then print out the date and the contents, and then we'll ask them again for another option in the menu, and this time they decide to enter 3, and the application terminates. Alright, let's get coding. Let's implement this project throughout the section. I'll see you in the next video. Hi guys and welcome back. In this video we're going to be creating the user menu for our project so that we can start interacting with users and looking at what our program is going to do. To create the project, I've gone ahead and made a folder. I've called it project logic of our application. Here, we're going to start off by creating the main to be menu that our users. So I'm going to handwritten that out line string, and we've got the please select one of the following options, the 3 options, and they're selected space at the so that users can go ahead and type after this. We're going to pass the variable to the input function so that users can type what they want. As well as we're going to need some sort of variable that we're going to show at the very start of our application. So here I've created those 2 variables now. The next step is to have a loop that is going to run continuously asking the user what they until they enter the number 3. So what we normally do we use a while loop. So the first thing is to get user int, and we're going to make that equal to the input of menu. So we're going to ask the user, showing them this prompt what they want to do, and while user input is not equal to the input function always returns a string, so we need to compare against the 3. Then we're going to run our menu. We're going to do here whatever the user wants to do. So we'll deal with user input here. Then at the end of the menu, you ask the user again. We'll say user input equal input of menu. In just a moment, we're going to find a way of writing this menu so we have education. First of all, we ask the user for their choice. If it's not 3, we do what they want us to do, be that 1 or 2, and then we ask them again. When we ask them again, we go back to the top of the while loop and check again. If not 3, we run this again, and then we ask them again, and so on. Reduce, we can use a new feature of Python 0.8 if you're using Python 3.8. the was operator or the assignment expression. The assignment expression allows us to put this input statement right in here, like that. And this is while user input, which should be equal to the input of menu, is not equal to 3, we will then run this code here. Now, very important that the was operator or the assignment expression has lower precedence than the comparison. So when we write it like this, what we're actually doing is we're saying while user input is equal to whether input of menu is not equal to 3, then we will this code. So what this is really doing is assigning to user input whether the input is equal to 3. So this will end up being true or false. It's not actually going to the contents of what the user entered. So we have to put some bracket around so that this evaluates first. And now this is what we wanted. We first put the value of calling input of menu, and then we compare again, is not equal to it. Now when we run this code here, the user input variable contains what the user typed. So that's what we wanted. So again, this is a new feature on Python 3.8. If you're not using Python 3.8, you can use what we just typed a moment ago instead. Now with our user input, we can go ahead and write a series of if statements that we can use with the different options. So if the user input is equal to 1, then we will add. So we'll say adding. And for now, I'm just going to put this print statement in here. We're going to add for just a moment. Guys, if the user input is equal to 2, then we're going to print viewing. And again, later on, we're going to actually be displaying the entries, their entries list. Otherwise, if it's not 1 or 2, but we know it's not 3, because if it was 3, we wouldn't be running this code to begin with. So otherwise, we know that it's not 1, 2, or 3. It must be something else at the time, and that's an invalid option. So we're going to tell them, invalid option, please try again. So these are the 3 different branches of our if statement, and will allow us to start thinking about our menu a bit better by seeing it in code. Of course, remember, we still have to use this welcome variable there to welcome users to our application. We're going to print that at the top outside of the because we only put that once. Let's complete code for the UI. Next up with the functionality to keep track of entries, but we're not going to use a database. Just going to add SQLite later in the project. First, we're going to develop our program logic using a Python list as a database table, and then we're going to use it later on. Using a list instead of it allows us to quickly develop our program without worrying about interacting with it yet. Once we're happy with all our functions and how we can read and write from the database instead of from the list, and changing that will be straightforward. This we have to worry about one aspect of software development at a time. Alright, in the next video we're going to look at what is SQL, and we're going to come back to this code and use Python as a database. I'll see you in the next one. Hi guys, and welcome back. In this video we're going to learn more about SQL. So what is SQL? How do we use it? What does it mean? What's it for? SQL Relational management system, called Rdbms, and the 2 terms that we're going to learn in this lecture: structured SQL or SQL and Rdbms. SQL is meant to be English in some way. So the queries or the things that you use it for sometimes English, or they are meant to be reminiscent of English. And now, they're not exactly English by any stretch of the imagination. Here we want, for example, a SQL query command to find some data in a table. Here we're finding data pertaining to, that's what from users means at the end, and we're selecting the first name and the surname from each user. You can see how this is somewhat similar to English, but obviously this in English. Now, to insert data, for example, as another we'll review these in a lot of detail as we go through the course, but just another example into the users table, then we specify the columns that we want to insert, but again, we'll look at that in more detail as we go along. At the very top, in the first bullet point here, we mentioned that SQL is used to interact with relational systems. So what are relational databases and what are Rdbms's? Well, Rdbms's are large, complex, and powerful. And some examples of them include PostgreSQL or even SQLite. SQLite is a Rdbms, and it's less powerful, but it's also more flexible in terms of how you can use it. So we're going to learn more about what I mean by that as we go. Databases are primarily constructed from tables. Tables have columns, and they can have 0 rows if the table is empty. So here we've got an example of a table. It's 2 columns, first name and surname, and then we've got 4 rows of data. John Smith, Rolls, Anpan, and Robert Baratheon. Some things that may stand out. You can have duplicate values. Each row is independent, so you can duplicate 2 rows, and that's totally fine. But there are ways to prevent that if you wish. Learn. And you can see that every cell, every row and column combination has a value, although there are ways to allow empty values, and we will learn more about that later on as well. Yeah. So why relational? What does the relational term mean in the name RDM? Well, it's to do with how tables are used together. Obviously, for something to be related, so you can see how these 2 tables here are related in a way. And the surname columns there in the users table, let's call it. And an account table, and this one has the holder and the account number of person. You can see how they are related because clearly John Smith, the first user on the left, is third and has this account number 9586859. So these are tables, and SQL and Rdbms allow to follow that relationship and make it so that the relationship is very easily usable. To simplify, we often use unique identifiers for each row. We're going to give each row in both tables a unique identifier. Here you can see Rolf Smith got the ID 2, and so on. Now that means that we can refer to each user with just the number, because these should be unique. Similarly, in the table, we've also gone and given each row an ID. You can see now that the account 1 is for Anpan, and this is the account number. I've gone further and also gave them an ID of the user that should match. So you can see that the account with ID 1 is for user with ID 3. So we can then go to the users table and grab user with ID 3, and we get Anpan. See, if we do this, we no longer need the holder column here. B already allows us to go to the users table and grab the name. We don't need to have the name here as well. So we can just get rid of that. And this is a very common approach for it. You see what pieces of data can be stored in its own table, its own meaning, and then you can reference those tables from other places. We're going to be doing a lot of this throughout the course, so don't worry if it's not so obvious at this point in time, but we're going to be learning a lot more about how to do this. And through smart querying of the accounts table, we could find the user's name, and similarly, through some smart querying of the users table, we could, for each person, find their account number. Both ways, and we can use them very flexibly. So let's go on about those queries at the start of this presentation in the next few videos. I'll see you in the next one. Hi guys, and welcome back. In this video, we're going to start using Python lists as a database instead of SQLite. We're going to do this first because it's simpler. Then when we want to use SQLite, the change over will be very straightforward. When you think about it, lists and database tables are very similar. They are both used to store individual items. Inside a database variable, we store rows of data, and each row can have multiple pieces of data, one per column. Inside the list, we can store anything we like, including dictionaries. Each dictionary can contain multiple pieces of data as well. So here I'm going to show you sort of a sample dictionary that we might store in our list. So here we've got our entry list. This is what we're going to be storing in our application. And you can see that it's a list, and inside it we've got 4 dictionaries. You can imagine that these things are things a user created. So we've got the content key that contains what the user learned on that day, and the date key that contains when they learned it. Initially, our entries list is going to be empty, and we will be creating a dictionary every time the user adds a new entry and putting that dictionary into the list. So this was just an example, but let's go ahead and write this code out. The first thing we're going to do is create a separate Python file to host the logic that interacts with our data store. At the moment, as I said, this is going to be a list. Later on, it will be a database. So I'm going to open my file viewer there, create a new file called database.py. Then I'm going to close the file viewer. Here, we're going to create our entries list, which is this empty list initially. And now we're going to create a couple of functions just to allow us to add a new entry or view existing entries. So here is the add entry function. Notice I've used the pass keyword, which means do nothing, to allow Python to still process this function as valid. It does need the indented block in there to be valid, but at the moment this function does nothing. And we're going to do something similar for view entries with pass as well. So now we've got our 2 functions. We go into app.py and import these functions. And that is what we will do indeed in just a moment. To begin with, we're going to use this add entry function to ask the user for what they've learned and when they learned it, and add that to the entries list. So we will create this entry content variable, which is going to be an input of what have you learned today. And also the entry date, which is another input of enter the date. So here we've got 2 strings. The date is not being validated or anything like that, as we spoke about earlier on in the presentation. And what have you learned today? The user can enter anything they want. Now that we've got those 2 pieces of data, we can create a dictionary with them. And the dictionary should have a content key, that is going to be the entry content, and a date key, which is the entry date. Now, creating the dictionary on its own, of course, is not going to put it in the list, so we do have to do that ourselves. Entries.append, and we will add it in there. So here we can see that we are appending into the entries list our new dictionary that we create here. To view the entries, we can similarly go through the list and print out each entry information. So we can do for entry in entries. Here, this for loop creates the entry variable every time we go through one item of the entries list, and the entry variable initially will be the first item in the entries list. We will then run this indented block of code here. We will go back and entry will become the second item in the entries list, and then we will run this block of code and so on. Again, this is all covered in Python Refresher, so if you have any questions about for loops or dictionaries or lists and things like that, do go back and check that out. Now, for every entry in the entries list, we want to print out the information. So we're going to print, and then in an F string, we're going to put the entry date, and then in a new line, we're going to put the entry content. Then we're going to put 2 new lines. So a couple of things going on here. This F string is a little bit complicated. We are interpolating into the string the value of accessing the date property of the entry. So notice that here we're using double quotation marks at the end and the start of the string. The access of the date property in the dictionary must use single quotation marks. Otherwise, we get confused and it would think that this is a string and this is another one. It doesn't like that. So make sure to use single quotation marks there. That's the date of the entry. Then we're putting a new line with a backslash n character. And then we're interpolating the content into its new line. And finally, we're putting 2 new lines there so that when we print the next entry, there's going to be a bit of separation between the 2. Okay. So now we're going to save this file and we can go ahead and use it in our app.py. So make sure to save it. We can go over to app.py and now we can import those 2 functions that allow us to interact with our data store here. So we'll do from database import add entry and view entries. Now, once we've got that, we can go down into our menu and just use them instead of print adding and view. So we'll do add entry here, make sure to call the function, and view entries in here. Now, if we save this and run it, you'll see that it all works. So I'm going to open up the terminal down here. Just going to make it a bit bigger. I know the text here is a bit small, but hopefully you can read it there. And now I'm going to run Python 3.8 app.py. Remember, we've used the walrus operator, or the assignment expression, so we need Python 3.8 for this code. Here we've got our menu. We can then add a new entry, for example. And when we type 1, of course, we are running the add entry code. That's taken us to database.py, and now currently on this line. So what have we learned today? We've learned how to use Python lists as a data store and enter the date. The date can be today. Note that there is no validation on this date, so we can enter whatever we want. Now, if we want to view entries, we enter 2, and then we get today, and then a new line. We get the content of the entry, and then 2 new lines, and then we would get the next one if there was more, but now we just get the menu. Finally, enter 3 to exit. Okay. Just going to make that a bit smaller again, and I'm going to clear it, which gets rid of all that text. Now, there is a glaring problem in the way we've structured this application, and this problem may not be all that obvious if you are not that familiar with coding, but I'll tell you that it is a glaring problem for any developer that's a bit more experienced. The problem is that the database.py file is doing really 2 things. The database.py file is interacting with the user, gathering data, and it's also storing data in a database. So it's doing these 2 separate things, and it can become confusing and complicated to then change the data that we're storing or how we're gathering it. It's usually better to have these 2 things separated. Have one part of our application dealing with getting the user input and have a different part dealing with interacting with the data store. Similarly, the view entries function is retrieving data from the data store, and it's also outputting data to the user. So it's doing those 2 separate things as well. Overall, this file here gets data, processes data, and displays data. So yeah, it's not a great file at the moment, but we can make it better. Up until before we made this database.py file, the app.py was in charge of dealing with user input and displaying information. So why don't we keep it that way? We will move all the user input gathering and data display to app.py, and we will keep database.py as only dealing with the database. So how to do that is we're going to move these 2 inputs over to app.py, and we're going to pass their contents to add entry. So I'm going to add 2 new parameters here, entry content, entry date. And now this function here is only concerned with taking the data it receives and putting it in a database. It is going to be app.py going over there now that is going to ask the user for data, and then it's going to call the add entry function with the content and the date, just like that. So now we're getting the user input, storing it in a variable, passing the value of that variable to add entry, and then add entry is receiving that value and storing it in the database. Similarly, if we go to data.py, we've got here this for entry in entries that is displaying information. Instead of that, we're just going to make view entries responsible for getting the data from this list and giving it back to the caller, whoever used this function. So we'll do return entries. At the moment, this may not seem all that useful. Later on, when we're actually interacting with a database, you'll see why this becomes more important. And I've copied the for loop there, and I'm just going to move it down here for entry in entries there, and I'm going to get the return value of view entries and put it in a variable as well. Notice that you could grab the function here and put it directly in the for loop. That's totally fine as well. Either option works. Now, notice that the function is called view entries, which suggests that you're going to be able to see something. But the view entries function is no longer concerned with actually displaying data. So we're actually going to rename it to get entries instead. So we do have to rename it in database.py down here and in the import as well. This makes app.py more complicated, but it makes the whole application simpler because now reading app.py, I have a clear idea of what database.py is doing. It adds and gets entries from a data store. And we've also made it clear exactly what data we're adding to the database. Previously, that was hidden inside database.py. We were calling the function, and we didn't really know by reading this whether database.py was asking 2 pieces of data or 10. Now it's a bit clearer. And app.py, as you read through it, you can see exactly what the user is going to see as well. We could improve the code inside app.py a bit further, splitting it into functions. So this stuff here could go into its own function. This stuff here could go into its own function. We're going to do that just now as well. We need to define functions before they're used. So we're going to go up here and create a prompt new entry function. And this is going to do all of this stuff. So I'm going to copy that into there. And down in here, we're just going to call prompt new entry. So I prefix these functions with prompt because they're actually interacting with the user. I like to make that a bit clear. And then we're going to create another function for viewing entries. And this time it is going to be called view entries, but I'm going to make it take in the entries from the database itself. This one here is just going to go through the entries and print them out. Now, when we've got the entries, we can just call view entries with the entries list that we got from the database. Now, this is starting to become a little bit too superfluous, this entries database, so I'm just going to copy that and put it in, get rid of that variable. So while this code is now a bit longer than before, it is a bit simpler because it's more divided into parts. When you read this function, you know that we're going to be adding a new entry. And when you view this one, you know we're going to be displaying entry information. And finally, the loop now is very simple. If the user inputs 1, then we prompt for a new entry. And if it's 2, then we view the entries. So hope you agree with that. Now, in the next few videos, we're going to be replacing the Python lists for SQLite. So let's go and do that